All right, today's statistical topic is types of data in statistics. A major use of statistics is to collect and use sample data to make conclusions about entire populations. That's pretty much all we do, because obviously we can't look at the whole population, that's way too many people. So we just take a small sample and then we try to figure out what is going on based on those sample results. All right. Parameters, it's all going to be about vocabulary here for a while, ladies and jelly spoons. Parameter. A parameter is a measurement that comes from your population. If you're talking about a measurement that comes from your sample, we call that a statistic. Hence the reason we call the field statistics, because 99.9% of the time we are looking at samples. We are not looking at parameters. We are looking at statistics. So very important difference. Parameter goes with population, statistic goes with sample, PMP, SNS. Very easy way to remember that. All right, the data you collect could be quantitative, which means it's a number. It's numerical data. It's shoe sizes, heights, that kind of thing. Weights, ages. There's lots of numbers that we could be talking about. If you're talking about categorical data, this is called qualitative data. Sometimes it's called attribute data. And this consists of names or labels. It's not going to be numbers. It could be your gender. It could be the number that appears on the shirt of your uniform. That is considered categorical. It could be substitutes for names. There's lots of different things. It could be your favorite color, your favorite food. I mean, there's lots of different things that we could talk about when it comes to qualitative data. So quantitative versus qualitative. Big difference between those two things. When you're working with quantitative data, you want to make sure that you know what kind of data you have. You could have discrete data or you could have continuous. Discrete is when you can actually count it. There is a finite number. Like if you're talking about tossing a coin, there's going to be a number of times that you're going to toss the coin, right? You can't toss the coin 2.5 times. You can only toss it 2 times. You can toss it 3 times. So that's what we would call discrete. We can actually count it. But continuous data is different. Like if I'm talking about the number of measurements that I can find between 0 centimeters long and 12 centimeters long, there are an infinite number of lengths between those two. And so we would call that continuous because we cannot count every single possibility that we could measure between 0 and 12. There are levels of measurement, and this is where students usually have a lot of troubles when you're talking about levels. So the first level of measurement, there's 4, by the way. There's only 4, so that's the good news. Nominal, ordinal, interval, and ratio. We're going to talk about each of those 4. So the first one is nominal. So nominal is when you're getting the data that can't be arranged in a certain specific way. So like if you have a problem, if you have a survey question and the answer is yes, no, or undecided, is yes more important than no? No, not really. Is undecided more important? I don't know. So those are things that you can't put in any kind of hierarchy or order. So that would fall under nominal. There's ordinal. Ordinal is where you can put the data in a very specific order. But if you just looked at each one individually, it would be kind of meaningless. So like a perfect example is when you're talking about grades, right? In our grading scale, it's A, B, C, D, and F, right? Pretty straightforward. And we all know what's more important, right? A. A is the best grade, then B, then C, then D, and F is the worst. But if I just told you, if I didn't tell you that that's how we arranged it, maybe you thought A was the worst and F was the highest. So it depends on that. But there's a very set hierarchy amongst those data points. All right, the next is interval. This one's tough. I'm going to be honest, I have a hard time with this one myself. This is where you have no natural 0 in your data points. And they give the example in your textbook as years, which I don't really like because there actually is a 0 when it comes to years. However, it depends what system you're using, what your 0 is. And I think that's kind of their point here. So if we're using the way that we measure time, like this is the year 2023. All right, so obviously there had to be a year 0 at some point, right? We had to have a starting point. But that could be different depending on what system. Like the Chinese don't measure time the same way we do. Very different. So we have to make sure that we are taking into that into consideration. But there is no natural starting point. Like, do we know when time began? No, we don't. We know when we began numbering our years, but that's not when time began. So again, this one is kind of a little gray area for some people. Ratio I like the best because ratio is very straightforward. And if you remember anything from algebra, a ratio is when you compare two numbers to each other. That's it. You're just comparing two numbers to each other. So like if you say that a class time is 50 minutes here and it's 120 minutes here, what is the ratio, right? What is the ratio of those times? Obviously one class is twice as long as the other one. That makes sense to me. So there is a natural zero here in this. And that ratio is like the easiest way to represent that. So personally, I like the ratio one. That's my favorite. That's the easiest one for me to remember. In your textbook, there actually is a very nice little chart, so I have put it here. Just a summary. So nominal is categories only. Ordinal is categories, but there's some order. Interval is differences in numbers, but those numbers have no natural 0 point. And ratio is differences and there is a natural 0 point. And then in this chart, they give you some nice examples that you can look at. And again, this is in your textbook, so you don't have to write it down. All right, so that is today's lesson. Oh, wait, not yet. I lied. There's more. I forgot to talk about data. All right, so let's talk about some data points. If you're talking about big data, what does that mean? Big data means it's like big pharma, right? It's so huge and complex that you really can't analyze the whole thing all at once. And there are data sets that are so huge that if you try to put them into StatCrunch, which you have in my math lab, or Excel, it would implode because it's just too big and there's too much. So if you have big data, you may be, needing several servers running software packages all at the same time to calculate all of this stuff. So we tend to shy away from that in our class because we don't have the capability to do that. We're going to look for the smaller data sets, some more finite, discrete data sets that we can actually count and that aren't huge. Data science is a really big part of statistics, especially when you get into these big data sets, because you are going to need software packages and you are going to need some computer science people to help you running multiple servers in tandem. And this involves a lot of money and a lot of time. So if you decide to go into the computer science end, you will be doing a lot with statistics, just not what you think you're going to be doing. You're going to need software engineers to write these packages for you that will do all this. Especially if you're working in fields like sociology, you're going to have a lot. Finance, like if you work for a bank, you're going to have computer science people and IT people and software engineers all the time helping you because banks deal with billions of transactions a day. So that's what we mean by big data. Another issue that comes up is missing data. What do you do when you're missing some data? Do you fill it in? Okay, do you not fill it in? Do you make an educated guess? There's lots of options that you have when you have missing data. Sometimes the data is missing at random, meaning maybe it just disappeared for no reason. Maybe the person who was filling it in just like absently minded skipped that one question. We don't know. But there's no one data value that's more likely to be missing than another. So like if you're giving a poll, this is a good example because this actually happened once. If you're giving a survey and you had all your questions on one page but only one question on the back, and the people didn't flip the page over to answer that one question on the back, that is not at random because, right, people just didn't turn the page over. They thought it was the one page on the front. They just filled it out and turned it in and didn't realize there was stuff on the back. So that would not be missing at random, right? That's why people missed that one makes total sense why. So again, that just goes back to how did you format your survey? Kind of important. But if you had a two-sided survey and you let people know and everybody answered it, but like this guy forgot question 17 and this guy over here forgot question 12, that's when you're just missing at random. I don't know why those people didn't answer those questions. So that's, again, also things you have to think about when you're talking about data. When you're correcting your data, this is where you have to think about. Do you delete that case? So you have to decide at the beginning, if somebody skips this question, am I going to use their data at all? Or am I just going to delete that subject from my survey, from my results? And that happens a lot, especially if you're doing medical surveys. Or any kind of medical, statistical, experimental thing, you have to make sure that people don't miss anything. If they miss stuff, you have to delete them from yours. And if you do have a missing value, another thing that people like to do is they like to calculate the value for them. Like, what do they think the answer would have been for that person for that particular thing? Be very careful when you do this because if you do this too many times, or say that what you're using to create the answer is biased or flawed. This could get you into some hot water, especially when it comes to when you have to defend your analysis to other people. This could get you in hot water. So again, there comes a time and a place for both of these situations, but I usually tell people delete if you're not sure, because you want to make sure that your data is as pure as possible. All right, so that ends our discussion today. Hopefully I will see you next time.